Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good night everyone. Okay, can you hear my voice? Can you hear me? Okay, so tonight we are going to continue frame analysis using moment distribution method. Okay, frame analysis using moment distribution method. Okay, so we consider this frame. This is ABCD, ABCD. So column AB 6 meter, column CD 5 meter. Okay, this frame is subjected to point load 1 meter from point B, Okay, and there is a uniformly distributed load along member CD. E is constant. The value is 200 GPa. And I. Okay, I is not constant. So we have different value of IAB, IBC, and ICD. IBC and ICD. So this is BC. IBC. IBC and ICD. Okay, so using moment distribution method, okay, calculate or determine, calculate and moment. Calculate and moment. Using moment distribution method, calculate and moment. Okay, calculate and moment. And first thing to do, when we want to analyze this type of frame, okay, check whether it is SIDESWAY or SIDESWAY frame or no SIDESWAY frame. Okay, remember the two conditions for no SIDESWAY frame, it is symmetry and properly restrained or fully restrained. Okay, looking at this frame is not symmetry. This frame, okay, number one, this frame, okay, what we can get from this frame is unsymmetry frame. The frame is not symmetry. So this frame is not symmetry. Due to loading also unsymmetry, due to geometry also unsymmetry. It's not symmetry or unsymmetry. Due to loading and geometry. Okay, the frame is not symmetry, unsymmetry due to loading and geometry. And it is unrestrained. Apa lagi info we get from frame? This frame is unrestrained. So this is unrestrained. Okay, so unrestrained means that in this frame, okay, there are combination of external loading and delta. Combination of external loading and delta. So in this frame we have external loading. Okay, we have external loading. We have external loading. External loading P and W. Okay, the frame has external loading P and W. This one will contribute to FEM value. So FEM due to external loading. And next is, okay, the frame is SIDESWAY frame. This is SIDESWAY. SIDESWAY frame. And for SIDESWAY frame, it has delta. It has delta. Okay, and this also producing FEM. Okay, external loading P and W. P when it is subjected not adjoint. If P is subjected adjoint A, adjoint B or adjoint C, whether it is vertical or horizontal, we do not consider it as fixed end moment, because fixed end moment we determine we want to distribute moment to the nodes. So 250 subjected on member BC, so that is fixed end moment. Okay, CD W subjected along member CD, it is fixed end moment. It gives fixed end moment because we have to distribute the loading to the nodes. Okay, and we have FEM, which is come from delta, because please remember we calculate FEM because of two condition. We calculate FEM because of two condition. We calculate FEM, number one, due to loading. Number two, due to delta. Due to delta. For loading, FEM due to loading, okay, if we have like this, okay, B, C, 1 meter, 4 meter, 250. Okay, so this is FEM due to loading. Okay, and we have another one. We have C and D, UDL, C and D, UDL. So this C and D, UDL. So this is 40 along 5 meter length, 40 kilonewton per meter along 5 meter length. Okay, so this is equivalent. This is equivalent, yeah. This is equivalent. Okay, this is 40 kilonewton per meter, C and D. Okay, so all this we calculate FEM due to external loading. External loading. Because in this frame, it has combination of loading and delta. And please remember, we cannot calculate together between external loading and delta. We cannot calculate it together. We have to calculate separately. Then we have to plus. That is why we have to apply principle of superposition. We apply principle of superposition. Okay, we apply principle of superposition. Apply principle of superposition. Okay, we apply principle of superposition because we want to find the end moment, the final end moment. Okay, final end moment. Satu is end moment from external loading, and moment from FEM, from external loading. So this is it is M naught plus M. Okay, M naught plus M. So M naught is from external loading, and M is for delta. M naught is coming from external loading, and M is coming from delta. Okay, because we cannot calculate it together. We have to calculate it separately. So for external loading, we calculate using formula given in appendix. Okay, so we have two types. here BC subjected by 250, and CD subjected to W 40 kilonewton per meter. So these two types, okay, is under external loading, and we have to consider as well the FEM due to delta. So that is why we have we have to apply principle of superposition, because the end moment that we want to calculate must consider both. So we have final end moment, we have end moment M naught from external loading, and end moment M from SIDESWAY. Okay. So I have explained in class the summary of procedure. So number one, this is summary of procedure. Step number one, we have to calculate K and DF as usual. K and DF, in this case, I is not constant, so careful, yeah. Okay, step number two, we will calculate, we will analyze no SIDESWAY frame. No SIDESWAY frame. Okay, no SIDESWAY frame. So under this step, number one, okay, to analyze no SIDESWAY frame, we have to calculate FEM due to loading, external loading. Number two, 2A, 2B, from the FEM, we put into the table and we will do distribution moment, repeat 5 or 6 times distribution, and the output from the table is end moment. So end moment we call as M naught, and this is actually for table 1. Okay, and after that we have to determine what we call as restraining force. R. Okay, so this is step number 2. Step number 3. Okay, step number 2. But before that, step number 2, we have to analyze the frame. We have to analyze the frame. So the frame is like this, fix and pin. Okay, UDL point load. Okay, looking at the frame, based on the on W given, so we can assume that the frame, the original frame is tend to sway to left direction. So we have to apply an artificial support at B, and due to that there will be R here. Okay, so this is the frame under step number 2. This is how it look like. Okay, this is how it look like. So we have to analyze this. Okay, later on I will explain in detail. Okay. Number 3 is SIDESWAY frame. Number 3 is SIDESWAY frame. We have to analyze SIDESWAY frame. Okay, SIDESWAY frame, and this is table number 2. Under table number 2, it is analysis of SIDESWAY frame. So we have ABC as well. Okay, A, we have to calculate FEM, but this time we consider delta. Previously under step 2, we consider loading for the FEM. This time analysis of SIDESWAY frame, this we consider delta. So FEM due to delta, but this is delta prime, and this is based on assumption. Okay, delta prime. Okay, next step is B. So once we assume delta, we assume FEM, and then we will calculate also FEM based on the assumption for another column. And after that, we will use the FEM, substitute into the table number 2. Just change the FEM value. We still use the same distribution factor, and we repeat the process distribution carry over until the last distribution, and we get the final end moment M prime. So this is end moments. So this is M prime. Okay, and 3C, again we repeat the same procedure. We have to calculate restraining force. And this is R prime. So all that we analyze under step number 3 will be based on another frame, not frame. Okay, not frame. Okay, it is going to be like this. So back to the concept. So when we have frame like this, okay, this is just to represent the concept. The concept. Okay, we have frame like this. Okay, we have frame like this. And this is going to be 2 frame. By applying principle of superposition, we divide between external loading and delta. So due to that, we will have R here and also here R. Okay, loading remain. So if this is A, this is B, this is C. Loading remain under B, because at B we only remove delta. We remove delta by putting a pin support at C. So that is why R is exist. And R have to be neutralized. So that is why we get diagram C. Which is subjected to R only. So in diagram C, due to R, diagram C has delta. Okay, so if in table 1 give us M naught. Okay, table 2 is not M. It's not here. It's not this. Table 2 is not this. Okay, table 2 is not this. Table 2 is come from another diagram. Which is proportional. Okay, but change all to prime. Delta prime. R prime. Okay, so this will be delta prime. This is fixed. Okay, so this is diagram D. This is table 2 actually. And from table 2, we get M prime. So this is correct. Yang ni not correct. Okay, because diagram C, the delta is unknown. And we do not know the delta. We cannot assume C. We cannot assume FEM at C. What we can do is we introduce another frame which is proportional, and we do assumption in D. So we assume FEM here. Okay, in D. Assume FEM in D. And finally, we have to make relationship. Interpolation. To do interpolation. Okay, between M and R, which we get from C. And here we have, at D, we have M prime and R prime. Okay, so M is the unknown. M is the unknown. M prime we get from table. M prime we get from table 2. R prime we get from table 2. And R we get from table 1. Table 1. So in this case, by doing interpolation, we get M is equal to R divided by R prime times M primes. This is the concept. This is the concept. That is why when we move to analysis of SIDESWAY frame, so we have to consider diagram D. It is subjected to R prime. Sorry, this is R prime. It is subjected to R prime. The delta occur due to R prime is delta prime. And for the end moment, assume FEM. And then we have to do moment distribution in the table. In the table, at the end of the table, the moment distribution, we get n moment from table 2. We name it as M prime. This is n moment in table 2. So that is why when we analyze under step number 3, analyze SIDESWAY frame, table number 2, the FEM will be based on delta prime, not delta, because delta is unknown and remain unknown until the end of analysis. So the most difficult part is under this, yeah. Okay, FEM. So the rest will be the same because step 2B and 2C will be equal. Okay, the procedure B and C under 3B and 3C as well. So that is why for the final end moment, step number 4, for the final end moment, okay, I name it as MF, final end moment. It is MF. This is actually equivalent to M naught plus M, and M is equal to R divided by R prime times M prime. So this is the final end moment formula. Okay, and we are going to use this formula, okay, to get the final answer. Okay. Okay, analyze SIDESWAY frame table number 2. The diagram will look like this. Fixed pin R is moving to left direction because we want to neutralize. One is positive R, another one is negative R. So that R minus R, we get 0. Okay, R, we get this. This one is positive R. This one is negative R. So we will get 0, 0 in the original frame. Okay, so these are the two diagram that we are going to analyze. Okay, we have SIDESWAY frame, the upper one, and the lower diagram is the SIDESWAY frame. No SIDESWAY frame and SIDESWAY frame. Okay, so the first one here, we will calculate FEM due to loading. And for the second one, due to R, okay, we have to assume FEM based on the and then based on the geometry, we will calculate another FEM. So there are two FEM here. One is FEM for A, B. Another one is FEM for CD. Okay. So inside this diagram, we will get FEM for member BC, and another one is FEM for member CB, and then we also get FEM for member CD and FEM for member DC. So we have to calculate all this value. Okay. Okay, this 4 value is under table number 1, no SIDESWAY frame analysis. Okay, for SIDESWAY frame analysis, okay, we will get 4 values of FEM, okay, which come from FEM for AB, and this is equal to FEM for BA, and we have to make assumption. Assumption is 100 kilonewton meter, and it is positive because of behavior. Okay, and then due to this, we will calculate FEM for CD, and this is equal to FEM DC. So our task is to determine this value. Okay. So we start doing the solution now. Solution. Okay, we will start with step number 1. We will start with step number 1. Okay, we want to determine or calculate K and distribution factor. K and distribution factor. Okay, so in order to do that, I want to put all the value in the table. So, okay, I want to list all the members here. A, B, B, A. Okay, like this. A, B, A, B, C, C, B, C, D, D, C. Okay, so we have K, E only constant, so we can remain E in terms of E. Okay, and okay, this is for member AB, member BC, member CD. Okay, K for member AB. K for member AB. Look at the diagram. The diagram AB is far and fixed. AB is far and fixed, so we use 4EI over L. 4EI over L. K is 4EI over L. Okay, for AB, it is 4E. I is 400 times 10 power of 6. Okay, 10 power of 6, negative 6. Negative 6. Okay. We have to change the unit first. Change the unit first. The unit for I is given in mm. MM4 change to meter, we get 400. 400 times 10 power of 6 times 10 power of negative 12, M4. So we get 400 times 10 negative 6, M4. Okay. If you want to times the E value directly, doesn't matter. You can also do that. So we can get EI, which is equal to 200 times 10 power of 6 times 400 10 power of negative 6. Also can, Also can. So from this we get it is 200 times 400. Okay, 200 times 400. So let's say we just calculate by considering all. So we get K. Okay, so the value for this, so we put 4 times 200 E. I is 400 for EI. 4 EI divided by L is 6 meter. L is 6 meter. 4 times 200 times 400 divided by 6. 4 EI over L. Okay, please calculate for me the answer for this. 4 times 200 times 400 divided by 6. 4 EI over L for member AB. Please calculate for me. 4 EI over L. What is the value? 4 EI over L. 4 EI over L. We are now calculating K for member AB. K for member AB. We use 4 EI over L for far and fixed. Okay, 4, this is E, this is I. 53,000. Okay, so the value is 53,333.333. Okay, AB and BA is the same value, so we just write once. Okay, what about BC? BC, KBC. KBC, we also use 4 EI over L. So this time, it is 4 times 200 times 500. Divide by 5 kan? 5. So what is the answer? 4 times 200 times 500 divided by 5. What is the answer? 4 times 200, 800 kali 180,000 ya. 80,000 ya. Okay, so this is 80,000. 80,000. Okay, next we calculate KCD ya. KCD. D is pin. D is pin. So far end is pin. So the formula used should be 3 EI over L. So this is 3 times 200 times 600 divided by L is 5. 4 EI divided by 5. Okay, what is the answer for this? 3 times 200. 3 times 200 times 600 divided by 5. What is the answer? 72,000. This is 72,000. Okay, 72,000. Okay, distribution factor. Distribution factor. Okay, distribution factor. There are 6 distribution factor. 6 distribution factor. Okay, distribution factor for AB, since it is fixed end, this one is 0. Okay, distribution factor for DC, D is pin. It is equivalent to 1. Okay, now, okay, please calculate distribution factor for BA. Distribution factor for BA. Distribution factor for BA means 3,333.33, 3 or 5? 5. Okay, it is 5. Okay, divide by total. Okay, joint stiffness means that total 3.333 plus 80,000. So here is 53333.33 plus 80,000. So what is the answer? This is for BA. So table ni is, yang ni pecah lah ya. Okay, actually table ni dekat sini kena pecah one by one lah. Sama macam kat atas. K only we combine. Sebab K tu AB or BA is the same. Just to show you lah the calculation. So you boleh buat either one, either in the table, or you don't want table, you want to do it manually outside. Okay. Okay, what is the answer for this? 0.4. 0.4 This is 0.4. So if this is 0.4, another one will be 0.6. 0.6. Okay, next one is 80,000. DFCB. DFCB 80,000. This is 80,000. Okay, we divide by 80,000 plus 72,000. So what do you get? What do you get? Five to 6. Okay, 0.526 here, 0.526. 1 minus 0.526. 1 minus 0.526. 1 minus 0.526. Choose, okay, choose up to 3 decimal places. So we choose 0.526, yeah. So 1 minus 0.526 for CD value. The FCD is 1 minus 0.526, it is 0.474. 474. 474. Okay. So this is step 1 lah. Step 1, we calculate K and distribution factor. K and distribution factor. So we move to step number 2. So yang ni, this is just for calculation ya. This is just for calculation. So the value is inside the table. The value is inside the table. So we have 0 for AB because A is fixed. Okay, BA and BC total 0.4, 0.6. It is 1. Okay, representing total DF. DF at joint total is equivalent to 1. Okay, 0.526 and 0.474 total is 1, and DC pin support it is 1. Okay, so move to step 2. So we move to step 2. Step 2. Step 2 is no SIDESWAY frame analysis. This is for table number 1. Okay, to be able to do this, step number 1, we must draw the diagram. We must draw the diagram, because from the diagram we will use to calculate FEM, and after that we will use the diagram to determine the restraining force. Okay, so you have to draw the diagram with the free body diagram as well. So we have W, have point load, W. Okay, fix at A. Fix at A means we have to draw the reaction, the free body diagram at fixed support is like this, 3 unknown reaction, and we have one pin support at D, one pin support, okay, at D, representing by dx and dy. Okay, representing by dx and dy, and then we label. Okay, this is MA, AX, sorry, AY. We label just like we draw the free body diagram. AY, AX, AX, DY, DX. What about loading? 250 and 40. Okay, this is 250 and this is 40. Okay, so this is 1 meter, 4 meter, 5 meter. So this is the frame that we are going to analyze. Okay, so we have to know. Okay, another one, R, yeah. So we get R here due to pin support at B. Okay, there will be a restraining force. Okay, so this is the frame. No SIDESWAY frame. This frame is properly restrained frame, or sometimes we can also use the term fully restrained. Fully restrained means no SIDESWAY. Okay, no SIDESWAY. Okay, no delta means no SIDESWAY. Okay, fully restrained, no SIDESWAY, because delta has been removed by putting an artificial support at B. Sini B. Okay. So now we have to calculate fixed end moment. So A, we have to calculate fixed end moment. Fixed end moment. So we have two members to be considered. So this one is B and C. Point load 250, 1 meter, 4 meter. Moment is acting, behavior in this direction. So we calculate FEM. So FEM for this is 250. So check the formula. 250 formula. Okay, the formula for this, okay, look, please look at this carefully. So when we want to calculate FEM, okay, whenever the loading is subjected not at the center, okay, for the right side at C, so it is 250 times 1 square times 4 divided by 5 square. This is the formula. Okay, the formula. Okay, and to calculate FEM, at B, so it is 250 times 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 4 squared times 1 divided by 5 squared. So that is the formula. Okay, the formula is like this. So FEM for BC is negative 250 is P AB squared divided by L squared. This is the formula. Okay, AB squared over L squared, and FEM CB is positive P A squared B. Okay, divide by L squared. This is the formula. The formula we can refer to the appendix. Okay, we put later on the appendix. Okay, mana dia? This one. Okay, this is PAB squared. Nampak tak? Yang ni tadi. Okay, this is PA squared B over L squared. Okay, so at left side, it is PAB squared over L squared. Okay, that is the formula. P, to calculate the value for A ni, for A, this is A and B kan. So to calculate FEM at A ni, to calculate FEM at A, B ni squared. B squared. Okay, to calculate FEM at B, A yang squared. Okay, that is why we get AB squared over L squared for FEM AB. And for FEM BA, it is A squared B divided by L squared. Okay, dia macam cross lah kat sini, cross. Cross cross. Okay, this is the tips how to remember the formula. Okay, for A, FEM at A, okay, B squared. Okay, FEM at B, A squared. Okay, this is the formula. So back to this. Okay, please calculate FEMBC. What is the answer? PAB squared over L squared. 250 times, I just rewrite this, 1 4 squared. Okay, so what is the answer for FEMBC? 250 times 1 times 4 squared divided by 5 squared. What is the value? And it is negative. What is the value? 250 times 16 divided by 25, 160. It is negative 160 kilonewton meter. Okay, next one. 250 times 1 squared times 4 divided by 25. It is 250. 250 times 4 divided by 25. 250 times 4, 1000. 1000 divided by 40. So this is 40. Okay. So this is the fixed end moment for BC. Okay, what about CD? CD, we have, for CD, okay, when we calculate FEM, we assume all fixed. We assume all fixed, yeah? So this is C and D, loading, 40, and 5 meter. Okay? So moment is like this and like this. Okay, so we use WL squared over 12. WL squared over 12. So I believe this one, everyone remember WL squared over 12 for both. Okay, so we calculate the FEM. FEM for CD, it is negative. Okay, please calculate. W is 40. 40 times L is 5 squared over 12. WL squared over 12, 5. 5. Okay, and FEM DC is positive value. 40 times 25 divided by 12. What is the answer? 40 times 25 divided by 12 for FEMCD. What is the value? 40, 83. 83. So 83 negative 83.333, yeah. So kilonewton meter. 83.333 kilonewton meter. Okay. So this is for fixed end moment. Fixed end moment. Okay, next we move to step 2. Move to step 2B, 2B. 2B, we want to calculate end moment. Okay, and the symbol we use is M naught. Okay, so we have to draw the table. We have to draw the table. We list all the member N. Okay, we have A, B, B, A, B, B, A, B, B, A, B, C, C, B, C, D, and D, C. Okay, so distribution factor, it is 1, 0, 0.4, 0.6, 0.4, 0.4, 0.6, 0.526, 0.474, 526, 0.526, 0.474. Okay. Then we put the FEM. So FEM for member AB, is negative 160, 40, and CBCD, sorry, not AB, BCCB, So negative 160, 40, 160, 40, 160, 40, and 83, this is negative 83.333, 333 and 83.333. Okay, FEM. Then only I put the line. Okay. Okay. FEM. FEM is the first end moment in the table. 0 FEM, you don't have to put the zero value in the table. Okay, if you want to, doesn't matter, just put a value. So it is just like this actually. So FEM, and start with distribution. Start with distribution, continue carry over, continue distribution, continue carry over, continue distribution, continue carry over, continue distribution. 1, 2, 3, 4. Carry over, continue distribution. 5, and find the total moment. Okay, find the total moment. Okay. Okay, in order to do this, I want you to calculate manually, but I want to calculate using Excel, this value. Okay, the value using Excel, and later on you can check using manual calculation the value of M naught. Okay, so I open Excel. Okay, so I list member again, and moment again, AB, BA, BC, CB, CD, DC. Okay, so you do it manually because we don't have enough time. So I use Excel to find the value, and you just do manually for checking later on. Okay, distribution factor 0, 0, 0.4, 0.6, 0.526, and 0.474. Okay, and then the FEM, BC, at BC negative 160 and 40, and then negative 83.333, and for DC we get positive 83.333. Okay. Okay, the first step is distribution. First step is distribution. Okay, total moment at B means BA plus BC. BA plus BC, BA 0 plus BC times with factor. Okay, so it is 64. 64. 64, so 64. Okay, so the highlighted total must be 0 to check for equilibrium. Okay, total moment is BA plus BC, BA plus BC, BA plus BC times with factor is 0.6. The factor is 0.6. One by one calculation manually. So please refer to video last night. Okay. So this 4 value for checking the total must be 0. Total must be 0. If the value total, if the total is equivalent to 0, means that the analysis is correct. Okay. Total moment at C. Total moment at C is come from CB plus CD. total moment at C is come from CB and CD. So the total moment is 40 plus negative 83.333. I have changed sign by putting negative in front times with the factor. The factor is 0.526. So we get here 22.793. I want to use up to 3 decimal places. Okay, 3 decimal places only. Okay. And again, 1, 2, 3, 4, we should get 0 again. Okay, for checking. Okay, means that for this one, it is total moment at C is 40 plus with CD, FEMCD times the factor 0.474, 0.474. So we get this. Okay, 3 decimal places. 3 decimal places. Okay, so these 4 values total equivalent to 1 means the answer is correct. The answer is correct. Okay? Is this right? For distribution? For distribution? For DC, this is 1. Okay? 1 means that we get negative 83. Total moment at D is negative 83.333 times with factor. Time with factor 1. So we get negative 83.333. Okay. So this line is for the first distribution. For the first distribution. Next is carry over. Next is carry over. Carry over, we have to cross boundary. Cross boundary. Okay, means that 64. Okay, the factor is 0.5 and fixed. It is 64 divided by 2. Okay, cross boundary. 96. Okay, cross boundary is 96 divided by 2. The factor is 0.5. Okay, 22.793 cross boundary. The factor is 0.5, so it is divided by 2. Okay, so 20.54 cross boundary. The factor is 0, so this is 0. Okay, and pin, the factor is 0. So the 20.54 times 0, we get 0. That is why here, okay, so kat sini 0 because factor is 0. The factor is 0. And 83, negative 83 kat sini, negative 83 ni kena carry over. The factor is 0.5. Yang ni, the factor is 0.5 divided by 2. 3 decimal places. Okay. So this is distribution carry over. One cycle. Second cycle distribution. For the second cycle distribution. Okay, next is carry over. Okay, next is carry over. 3 decimal places. Okay, so can continue the process. Okay, this is distribution, carry over, distribution. Carry over, distribution. Okay, so this is the last distribution. So this is M naught, M naught. Okay, the table. Okay, the summation moment start from FEM. The summation moment. Three decimal places. This is 0 0. So I copy this and put in OneNote back. Copy. Okay. Okay, this is actually the table, the distribution table, table number 1. So please fill in this using manual calculation. So the answer is here. So just for checking. So we get the end moment M naught here, M naught. Okay, start from AB until DC. AB until DC. So this is AB. So this is AB, BA, BC, CB, CD, and DC. DC is 0 because of pin support. Because of pin support. So in the diagram, remember, member and moment means the moment acting clockwise moment. So whatever value that we get negative, so we have to follow negative sign lah. Okay, so this is step 2B step 2B. So yang ni continue and check the answer below Yang ni continue and check the answer as shown below in the table. Okay. So this is 2A. This is 2A. Next is 2C. 2C, we are going to analyze restraining force. R. So we are going to analyze this. So how to analyze this? We have to refer to the diagram. This is the diagram. Okay, this is the diagram. We are going to determine R value. So to determine R value, we have to have one relationship, one equation to get R value. So what is the equation? We call this as shear equation. Okay, to calculate the restraining force, so we have to relook at the diagram. Okay, so we have R. we have AX and we have DX. AX, DX. Okay, so from this, okay, we have to write what we call as shear equation. Kenapa shear equation? Sebab we have to analyze column, and shear for column is in horizontal displacement. When talking about side sway, it is delta, and the delta is in horizontal displacement. So it is in displacement that it is in horizontal direction. So it is R, it is AX, it is DX. Okay, as well as W40 ni. So included over M. Okay, so the shear equation is total Fx equal to 0. Total Fx is equal to 0. So we write one equation. Okay, one equation, we include all the horizontal forces we get from diagram. All horizontal forces. So it is including R, okay, R, AX minus DX minus 40 times 5. So this is the shear equation. So from this, we will rearrange and we write R is equal to negative AX plus DX plus 200, or 200 minus AX plus DX lah. Okay, this is R. Means that to calculate AX, to calculate R, we have to know AX and we have to know DX. AX and DX we will get from column analysis. Okay, it is column analysis. Okay, column analysis, we have to analyze column AB. So this is column AB. We have moment we get from table. Positive, 29.87 and 59.8. It is positive. So positive. Okay. AX, in this direction, AX. This is AX. 29.87 and 59.8. Okay, so this one we call this as static equilibrium. We get AX by taking moment at B. It is just like we calculate reaction at the support for simply supported beam. Okay, so we have to take moment at B because we want to calculate AX. So AX, to calculate AX, it is 59.8 plus 29.87. So this is 6 meter. We minus by 6 AX equivalent to 0. Okay, this is just like we analyze simply supported beam. Okay, and then we get AX equal to 59.8 plus 29.87 divide by 6. So we get AX. So this AX we will substitute into the shear equation for AX value. So we will continue DX to calculate DX, analyze member CD. We calculate DX and we will substitute into the shear equation as well. Berapa nilai ni? So what is the answer for this? 59.8. 59.8. This is column analysis. We do this because we want to get the AX value. 59.8, 59.8 plus 29.87 divide by 6. Divide by 6. What is the answer for this? 59.8 plus 29.87 divide by 6. 14. 14.945 kilonewton. Okay, we have two column analysis. This is for AB and we have to do the same for CD in order to calculate DX. So, we extract CD. Now CD, CD. So, now CD. At CD, look at the table. CD, we only have moment at C. Moment at D0. Moment at C, negative 105.95. Negative 105.95. So, this is the value. Negative 105.95. So, it is negative 105.95. The length is 5 meter. DX in this direction. DX in this direction. 5 meter here. This is UDL. This is 5 meter. This is 40. AX. This is AX. Okay. Sorry, DX. This is DX. DX. So C and D. Okay. It is just like we analyze. This, ya. Okay, DX kat sini. So, nak ada moment kat sini. So, ada UDL. Okay. So, it is just like we analyze simply supported beam. But the beam is horizontal. The column is vertical. Okay. Taking moment at C. Taking moment at C equals 0. Okay. Taking moment at C equals 0. Can we find DX? Can we find DX? It is negative 105.95 plus 40 times 5 times 2.5 plus also 5dx plus 5dx. This is equal to 0. Okay. One we get from moment at C. Another one we get from UDL. And then another one we get from DX. Okay, so negative 105.95 plus 40 times 5 times 2.5 plus, okay, plus 5dx, we get 0. So dx is equal to 105.95 minus 40 times 5 times 2.5 divide by 5. What is the answer? Divide by 5. The dx. (105.95) minus 40.5 times 2.5. 40 times 5 times 2.5. Divide by 5. Static equilibrium. This is static equilibrium. Okay, to calculate the AX. To calculate AX and DX. Negative 78.81. Negative 78.81 kilonewton. Okay. This AX and DX, AX and DX, we substitute into the shear equation. Substitute into the shear equation. R is equal to 200 minus AX plus DX. So it is 200 minus 14, 945, 945, okay, plus DX plus negative 78.81. Okay, what is the answer for R? 200 minus 9.4 or 14.945 plus negative 78.81. Okay, what is the answer? This is the R value. This is the R value. 106. 106.245 kilonewton. So this is R. Okay, this is R. So settle So this settles step number 2. Settle step number 2. Okay. So now we are moving to step number 3. Under step number 3, this is SIDESWAY frame. SIDESWAY frame. Okay, the delta is delta prime, yeah. Delta prime, this is for table number 2. Okay, so the diagram is look like this. Fix and pin. Okay, move to the left direction. R prime, R prime, R prime. So due to this, there will be delta prime. Delta prime like this, moving towards left direction. So the delta prime, okay, find the triangular. Always find the triangular. Okay, so this will be the delta prime. This is also delta prime. And we just need to assume delta, both delta are equivalent, sama nilai. Okay, sama nilai. Okay, focus on the behavior. Focus on the new position of the column after SIDESWAY. Okay, because it gives us behavior. Okay, so under this step 3A. Step 3A. So this is SIDESWAY frame. Okay, what is the characteristic? This is SIDESWAY. SIDESWAY. Moving towards left direction. Okay, the delta is prime, yeah. The delta is horizontal displacement in left direction. Okay. Okay, 3A. So 3A, we want to assume FEM. Assume FEM. Okay, choose one column. We have column AB, we have column CD. Okay, so delta is for column. Delta occur like this. This is the delta. This is A, this is B. New position is B prime. 90 degree. This is delta prime. Okay, so look at the behavior. So it must be perpendicular. It must be triangular. Okay, the delta is horizontal, means that the member length is vertical. Between delta and L, it must be perpendicular. Okay, So new position is AB prime. New position is AB prime. So there will be moment at A and B we call as FEM AB, which is equal to FEM BA. Same value, same behavior. AB and BA same behavior. So we assume the value is 100 kilonewton meter. Negative or positive? Negative or positive? Okay. So it is positive. It is positive moment. Positive moment. So this is positive. Positive moment. Okay, 100 is the value, the assumption. Positive is behavior. So that we push the FEM push the column after SIDESWAY move to its original position. Okay, again and again. So the frame after SIDESWAY is like this. This frame we apply moment in order to counter back the new position, the column to its original position. So we apply moment, apply macam ni. Then only the column okay will be vertical. The column akan jadi tegak balik. So we apply moment clockwise. So it is positive. So this is the assumption. Okay, assumption. 100. Okay, now we use the formula for FEM. We substitute the formula. Okay, the formula to calculate FEM AB is 6 AB, AB. This is IAB. 6 EI delta prime over LAB. This is the formula for FEM. Okay, and this is equal to 100. This is equal to 100. This one. 100. Okay, so EI, so the delta is equal to 100 times L is 6 EI delta over L squared, L squared. 6 EI delta prime over L squared. 6 EI delta prime over L squared. L squared. L squared. Okay, so it is 100 times L squared 6 divide by 6 times E 200 times AB, IAB is 400. So what is the answer for delta prime? What is the answer for delta prime? What is the answer for delta prime? 100 times 6 square divide by 6, 200 and 400. Okay, please calculate the delta prime value whenever FEM is 100. The delta prime 0.00000075 kilo. Tak ada unit lah. Okay, don't put any unit, just the value. Okay, just the value 0.0075 ya, 75. Okay, now Okay, now we want to use this value. We want to use this value into the FEM for CD. FEM for CD. So FEM for BC, no value because there is no vertical displacement. We only focus on the horizontal displacement. So another horizontal displacement is occur at FEM, CD, FEM, DC, okay? FEM, CD, FEM, DC. The formula is 6EI CD, delta prime over LCD squared. So now we substitute. FEM for CD, DC. Okay, how it look like? Okay, put here. Okay, CD also moving towards left direction. CD also moving towards left direction. Okay, C and D. The perpendicular, the delta prime. Delta prime, this is L. L is 5 meter. L is 5 meter. Okay, new position. New position is this. Okay, moment, we have to apply clockwise. The moment we have to apply clockwise. So FEM for DC also positive. FEM CD is also positive. So we just need to substitute into the formula. It is 6, E is 200, I is 600, delta is 0.0075, L squared is 5 squared. Okay, so this is the value. This is the how we calculate the FEM. So what is the FEM value? So FEM for CD and for DC. Okay, 6 times 200 times 600 times 0.075 divide by 25. So what is the value for FEM? What is the value? 216. It is positive 216 kilonewton meter. Okay, this 216 is actually ratio between, we get 216 because of ratio. Ratio ni we get from L, from EI, the ratio. So this is actually the two value, 216 dengan 100. 216 dengan 100 is the two FEM value we will put into the table. Okay, but before that, I want to show to you, okay, how we verify this value. Okay, how we verify this value. Okay, we want to check whether the FEM, the ratio that we get to 216 is correct or not. Okay, we get using ratio, ratio. So we have member AB. We have member AB and member BC. CD. Column. AB dengan CD. For AB, the first assumption 100 has been made for AB. It is positive 100. Positive 100. And the formula for AB is 6 E6. The formula is 6 EI and EIAB divided by LAB. Okay, 6 EIAB 6EIAB divided by LAB. That is the formula for calculating FEM, LAB squared. Formula to calculate CD, FEM for CD is also 6EI. This time is CD delta. Don't forget it has delta, delta prime. Okay, delta prime over LCD squared. Okay, so put the value. The value is 6 times 200 times I is 400 delta prime divide by 6 square. Okay, and substitute also the formula for CD. We want to find the ratio. 6, 200, 600 delta prime, and here is 5 square. So find the value in terms of delta prime. Find the value. Find the value. So calculate this and also this. Okay, find the value in terms of delta prime. Find the value. Okay, 200 times 400 times 6. Divide by 36. What is the answer? What is the answer? This is just for checking, to verify that the 126, the 216 that you get previously is correct answer. Okay, 6 times 200, 1200 times 400, 4800 divided by 36. 4800 divided by 36. Okay, 13333.33. So this is 13333.33. Okay. Calculate also 6 times 200 times 600. Divide by 25. Divide by 5 square. 6. 28800. 28800. Okay. If this is 100. Okay. Ratio. What is the ratio for this one? Okay. Ratio. If AB is 100, what is the value for CD? Interpolation again. This is 13333, 13333.33 and 28800. Okay. What is the answer for X? Using interpolation. What is the answer for X? We have X and 100. We have 28800 divided by 13333.33. Do we get 216? 28800 divided by 13333.33 times 100. 216, yeah? 216. Okay? Means that it is ratio. It is actually ratio. Because from the formula to calculate FEM due to delta is 6EI. Delta, in this case delta prime over L squared. This is the formula. So this is formula. Dapat 216, ya. So this is formula. Okay, this is formula. Inside this, we have EI, we have delta prime, we have L. EI, delta prime, and L. If EI constant, for example, if EI constant, delta also constant, L also constant. What is the ratio? Kalau semua constant, EI constant, EI for AB, EI for CD, same, EI and EI also. Delta for AB, delta for CD, delta also, constant value. L for AB pun 5 meter, L for CD pun 5 meter. What does it mean? What does it mean? FEM due to delta, due to SIDESWAY, okay, actually get influence from three factors. EI, the flexural rigidity, the delta, and L, length of member. If all constant value, same value, the ratio is 1:1 ratio. 1:1 ratio. If EI is not constant, then the value will be different. So that is why, okay, yang kita buat tadi tu is just to find the value based on the ratio. Okay, so if the value is 100 for AB, CD, if ratio is 1:1, so the value is also 100. This time EI is not constant, I is not constant, L is not constant. That is why we get 102.16. Okay, we get 216 because of the ratio. Okay, so we have option whether you want to use the method given in the textbook. Yang ni method given in the textbook where you samakan formula dan juga 100 tu, yang ni samakan macam ni, and then calculate what is the value of delta prime, and then use the delta prime value, substitute into FEM for CD, and then we will get 216. Or we can also use this. Okay, use ratio to determine the X value. So X also 216 because it will depending on EI, on delta prime as well as L. So we will use 100 and 216 into the table. So the table we go back to Excel. Okay, so now I want to move to table 2. Table 2, we have AB positive 100, positive 100, positive 100, positive 100. CB BC is 0, 0. CD DC is 216, 216. Okay, 216, 216. Okay, so now we get M prime. So the answer, okay, the answer is given in the last row. Copy this and paste to this. So this is table 2. This is table 2. This is M prime. This is M prime. This is table 2. This is M prime. Okay. So once we got this, we finish step 3A and we have to continue to step 3C. 3C, 3C ni we want to analyze restraining force. Restraining force. Restraining force. So this time is R prime. R prime. Restraining force This time is R prime. So we will start with writing the shear equation. Shear equation. Okay. It's writing the shear equation. The shear equation is total F. Okay. Total Fx is equal to 0. So to write this equation, we have to sketch. We have to sketch the frame. We have to sketch the frame. R. Okay. So A x prime previously we put in this direction, so we just follow. So this is dx prime, this is ax prime. Okay. So the shear equation we get from this diagram. We just focus on the horizontal forces. Horizontal forces in this diagram we get from R and we get from ax prime and dx prime. Okay. So write the equation. It is R, negative R, negative R, negative R plus AX. AX prime. AX prime. Okay, AX prime minus D. Minus DX prime. So this is equal to 0. So R prime, R prime. Okay, R prime. This is R prime, R prime, sorry. R prime, not R. R prime. R prime. Okay, R prime equal to, so bring R to the other side. Okay, bring R to the other side. So we get AX minus DX, yeah? We get AX minus DX. So this is the shear equation. AX minus DX. So again, we repeat the process, the column analysis. So for the column analysis, we have to analyze column AB and column CD separately. So for column A, okay, for column AB. Okay, for column AB. Okay, AX. AX ni kena ikut same direction, same direction. So AX. Okay, this is AX prime. Okay, moment. Moment is positive. The moment from table 2 is positive. 85 and 89, 88.9. 85. It is clockwise. 80. 85. 85 and 68.85. 68.85. The length is 6 meter. The length is 6 meter. So taking moment at B. This is A and B. Taking moment at B. Okay, taking moment at B. So what we get? What do we get? Okay, it is 68.85 plus 85 plus 85 minus 6 minus 6 AX prime. Okay, AX prime equal to 0. Okay, static equilibrium. Use static equilibrium. Okay, like this. It is just like we analyze simply supported beam, but this is column. This is column. So AX, AX equal to AX is equal to 68.85 plus 85 divide by 6. Okay, what is the answer for this? AX is 68.85 plus 85 divide by 6. What is the answer for AX prime? What is the answer for AX prime? What is the answer? It is 25, 25,642. 25,642. Okay, kilonewton. Okay, this is for column AB. This is for column AB. So we do another one for column CD. Okay, for column CD. Okay, we get C here and D. The length is 5 meter. The moment at C. Moment at C. 67.474. 67.47. It is clockwise. Clockwise. This is 67.47, 474. 67.47. Okay, only this. Because the moment at D is equivalent to 0. Okay, the dx is in this direction. Okay, dx. So dx so this is dx prime. Okay, so again, taking moment at C, taking moment at C, taking moment at C. Taking moment at C, it is 67.47. 67.47. 67.47 minus 5 minus ke positif. 67.47 also positif positif 5 dx prime equal 0. So what is dx? Dx prime. Dx prime. dx prime equal to 6747 divided by 5. Negative. Negative, yeah? It is positive. Positive. So it is negative. Okay. It is negative. 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 Okay. 67.47 divided by 5. 6747 divided by 5. So what is the answer for this? Negative. Negative. 13. Negative 13, ya. 13.494 kilonewton. Okay. So column analysis. Column AB, this 25.46642. And column CD, dx prime, negative 13.494. And then we substitute ax prime and dx prime into the shear equation. Okay, we substitute into this equation. Okay, we substitute into this. Okay, we substitute into this. So we get the R prime. R prime equal to AX 25642 25.642 25642 minus dx. So minus 13.49494. So what is the answer? 25642 plus 13.494. 39. It is 39.136 kilonewton. Okay. So we already got R value. So this is R prime value. So settle step number 3. We move to step number 4. Okay. Step number 4. So move to step number 4. Step number 4. We want to combine all analysis. Combine end moment from previous analysis. Okay, so we want to calculate final end moment. Final end moment, it is MF. Final end moment, MF. And MF, okay, by applying principle of superposition lah. So this is from principle of superposition. Okay, from principle of superposition. Okay, from principle of superposition, we get, okay, M, final end moment MF, final end moment MF equal to M naught, moment, end moment from table 1, M naught, okay, plus correction factor. Correction factor is R divided by R prime. It is R divided by R prime. R from table 1, from step 2, R prime from step 3, table 2. Okay, times with M prime. M prime. M prime. So this is the formula we get from the formula to calculate final end moment. We get from principle of superposition. So okay, R value, R prime is 39.136. R prime, this is R prime. R value, R is R. Okay, 106.245. 106.245, 106.245. 106.245. Okay, 106.245. Okay, simplify this. 106.245 divide by 39.136. Simplify this. What do we get? What should we get? Should we get? One oh 6.245 divided by 39.136. 106.245. Okay, we get 2.715. 2.715. M prime. M prime. So we use this to calculate final end moment. So I'm back to, okay, the table, the table. The table. Okay, M not first. M not, and then M prime, and then MF. Okay, M prime yang ni. Base value. Okay, this is 0. M not from table 1. Table 1. Table 1. This is table 1. Okay. Okay, it is M naught plus 2.715, 2.715, 2.715, 2.715 times M prime. Times M prime. M prime is B17, B17. So this is the moment. Okay. So this is actually the answer. So the answer is this. Okay. Okay, using this formula, so this is the answer. Okay, so final end moment for AB is 260.647. For BA, 246.737, negative 246.737. Okay, for BA and BC, BABC. So CBCD, we get negative 77.241 and positive 77.241. And DC is 0 because of pin support. So this is the answer. Okay, the final answer, the end moment for frame, okay, considering side sway as well as external loading in the frame. Okay, this is the answer. Okay. Do you have question before we end session? You have question before we end session? Do you have question? So what we have done tonight? So tonight we have discussed frame with side sway. So the main procedure, there are four steps. But main procedure is step number 2 and step number 3. Under step number 2, it is no side sway frame analysis. So table number 1, diagram B, we get M naught. So this is no side sway frame, where we have to calculate. Okay, we have to calculate. So R here. Okay, this is 250 and 40. So this is for table number 1. So we have considered all this. Okay, we get N moment M naught, and after that we calculate R value. And for table number 2, table number 2 is actually diagram D. From this we get M prime. So the diagram we analyze in D diagram is actually okay, subjected to R prime. So here we assume FEM as 100, and from 100 we get FEM for this as 216. So this is the value we substitute in table 2 before we get M prime. And then we continue the same process to calculate R prime value. So this is the main thing in frame analysis. We have no side sway frame, we have side sway frame. So table number 1, FEM due to loading. Table number 2, FEM due to delta, due to side sway. And the value is actually based on ratio between EI, between L, and between delta. So this is how we analyze. Okay, so thank you very much. Inshallah we will continue another example in another session. Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.